So just to introduce myself, I'm Christophe. I used to be a data engineer for 10 years, but recently, like 1 year ago, I co-founded Now, so Now Labs. What we do is Cursor, but for data teams. So we help people writing SQL pipelines, Python pipelines, or everything that is around like analytics engineering when it comes to building your data platform. We are a fork of VS Code, and we connect directly to your data warehouse to help you build stuff faster, better, without breaking anything. Also on the side, for the last years, I've been doing content creation online about data stuff. So I have a newsletter on blef.fr, and I'm also the co-creator of a conference in Paris. So if you're in Paris around November, check it out. So just to give a shout out to the thing I'm building for the last year. So it's called Neo. We are a code editor for data people. So you can try it out and download it on getnow.io. Just now, I start my presentation with the takeaway of the presentation, so you can keep along because the presentation has a lot of concepts, but there are like three main things that I want you to remember today. The first one is when building AI agent, the context engineering is everything. The thing that you have to focus on is how do you build your context, how do you curate your context, and what you do around the context engineering. Then the second thing is it's an advice. If you want to do agent stuff, try to build one from scratch without anything, because that's the best way for you to understand how it works. And obviously there are limitations, and we're gonna speak about it. So first, the presentation is building AI agent is data engineering. So first, I want to introduce what is data engineering and why did we do data engineering for years. So this is a good definition that I've borrowed from a blog from the Pragmatic Engineering blog on the topic called What is Data Engineering? So data engineering is the development, the implementation, and the maintenance of systems and processes that takes in raw data and produce high quality, consistent information that support downstream use cases, such analysis, machine learning, whatever, like automating human stuff, this kind of stuff. So we can resume like we can summarize the data engineering as something like this. It's a black box where you put data in and you get data out. It's kind of like a LLM in a sense, where in a LLM you put token in and you get token out. Data engineering is a bit like this. You ingest data into a system and you get data out to do some stuff with it. And this is a diagram that I've designed a few years ago that summarized what is a data platform. And actually, this is pretty accurate, I would say. Like a data platform is a data engine that sits on top of a data storage on which you run some code and you produce some assets. And these assets can be used to visualize data or do machine learning, deep learning, AI, whatever. And the perimeter of like the data engineers is the one in orange. Which is interesting because you handle how data goes in and how data gets out. So yeah, that's what it is. This is another diagram that is old DBT diagram that showcase what is data engineering and what we develop when we did like ETL or ELT, which is we load data into a warehouse. We have raw data that we transform with DBT, but can be transformed with anything else. On top of a warehouse, we get transform data that we use into a BI tool, but can be used for everything else like MCP, AI, or whatever. What we did for years was on top of all this concept of data that goes in and goes out, we built a lot of DAGs. When we do data engineering, we create DAGs. A DAG is a directed graph where we have like some operations. So here on the left is Airflow screen capture. On the right is Dagster. But in the end, what we were building when we were doing data engineering, we were defining task, operations, and relationship between task and operation. And it was like most of the time deterministic. So we had to start, for instance, here, get a PDF, do some kind of manipulation, image processing, then identification, then combine, and then we have like the final results. And it's something that we used to do as data engineers, like writing pipelines. Now let's jump on what's an agent. My way to define it is like this simple. It's a while loop on top of some token interpretation that is managed by a model that have been trained a while ago. And in terms of a way to phrase it is model is the brain, and tools that we give to the model are the real world anchor. That's how a model interact with the world. It's like the ground base. So just a model without any tool cannot achieve anything. So that's the major like leap forward that we did like in the last year, like bringing new tools, helping model understanding the tools that they can use accurately, and so on. So it's like a metaphor as well, but let's imagine we are building like a Formula One. The engine is the brain, so it's like the model, and the Formula One that we can do with a Mercedes engine is we can do either like a McLaren or a Mercedes, and we can say that we have different results, like in the leaderboard, like the McLaren is way ahead of the Mercedes, even if they use the same engine. The difference will be like the tools, so the choice of the tires that we do, the choice of drivers that we do, and so on. So that's really important that we curate the tools correctly, so we get the most of the results of the LLMs. For years, we were saying like most of the tools that exist online are GPT wrappers. That's a bit true, but there is like a real difference, which is if you take an ID, if you take whatever that exists around, the difference at the moment is like the tools and the way people define the tools, the way the orchestration around GPT is done. Actually, GPT is just like if you take just GPT, it's done. It's just a token production. But what you build on top, which is like tools, orchestration, is like the real intelligence. And so it's not really like only a GPT wrapper. When it comes like to code editing and terminal-based code editing, we have like this landscape where we have three parts, I would say. The first one is stuff that is like terminal-based, stuff that is code editing-based, so in ID, and stuff that is cloud-based. All of these tools, most of the times relies on the same models, but they don't have the same performances in the end. This is something that we can experience on Reddit. We have people saying, is Cursor Claude 4 better than the one in Copilot? I'm now using Claude Code in Windsurf and it's just better, but why it's just better? Anyone feel Claude Code works better in Kiro than in Cursor? Why it's better? I think like the small differences in the way the tools are defined make some use cases works better for some people in one of the other tool. This is one of the explanation, and the second explanation I would say is more sentimental. People have like non-rational explanation that on the why they prefer a tool to another. So this what I want to say is like tools and context management when it comes to AI models and when it comes to AI agents are everything. But what does everything mean? If I just take a step back and explain what is an AI agent, the simplest AI agent you can develop will be, I would say, 100, 200 lines of code. So it's this way. So here I just show you how you can call OpenAI API to just create a response. This is like just a one-way question, I would say, to the model. On top of this, we can add tools, the messages, and we can also call the API. This way, we're gonna give the model some a ground understanding. So I would say how the world works. Here we define two functions. The first one is read file. The second one is write file. And what we're gonna do is ask the model to do some stuff. Here I say, can you translate Christophe.fr.txt to English? In order to do this, the model gonna need to read this file. So use this tool. And I hope it will understand because I said Christophe.fr.txt. I would like maybe to create Christophe.en.txt. And so it will need to write the output into another file to do the translation. And in order for me to execute these tools, I need to interpret the tokens that are giving back that are given back by the model. So the way I will do it is with a while true, and I while loop around this API calls, and I treat the output, looks at the function call that are proposed by the LLM, and do stuff. So in terms of structure, like this is the most minimal agent you can develop. You have like a while loop, you have the token generation, you have the tool execution, and you have the context management here with the messages and the tools that are not in this slide, but the tools also are included in the context management. And this is how an AI agent is built, actually. This is super simple. You can experience this by yourself, and you will learn a lot. This is one of my key message of this presentation. When we look at what agents are today, we have, I would say, two kind of agents. We have the one that are task specific. So for instance, I want to develop a product that is doing one specific task or multiple specific tasks, but for instance, extracting information from a PDF, guess the intent or guess the amount of money or guess something in the PDF, extract some specific information. And then launch after the extraction have been done, some downstream task. This kind of stuff can be something hidden in the backend of a product. So for instance, I have a product that parse PDF results. Someone drag and drop a PDF, and then I launch some downstream task. And this is something that is more on the backend side of things. And there are like some chatbots, and the chatbots are more like agentic. They are more user-facing. They can be, they can like handle a very wide range of tasks. And the way we think of the chatbots should be a bit different. When it comes to task specific, this is a bit of the link with data engineering. What we would have been like, what we would have done 4 years ago was spin up an Airflow DAG with maybe 4 tasks, like read the PDF, extract the information, load the data into a database or a Parquet file or whatever, and then do like the whatever action we want to do downstream. This is super specific. This is something we were doing in data engineering for years. We had like specific DAGs. We know the input types. Everything is super structured. It's deterministic. And this is the way we would have done this PDF parsing thing years ago. But with LLMs, this thing have shifted a bit. Now actually we create DAGs, or we let the AI agent create DAGs, and the AI agents decide the routes he wants to take within the DAG. So we have some inputs. The inputs can still be like the PDF. Then we give it to the LLM. The LLM does this multimodal thing to understand what is in the PDF. And then we give to the LLM some tools, some subagents, some whatever, some stuff to do. And the LLM will decide what will be the next step within this cloud of tasks, and will guess or will do a unique pass every time a new input enters, because that's how this new orchestration of AI agent is done actually. So the LLM will decide which paths they take, so they create their own DAG at runtime. This is one of the main, I would say, shift that is happening around AI agents. But in the end, what we are doing with the LLMs is we have an LLM that orchestrates something, that orchestrates some tasks, and these tasks have to be run at some point. And actually, it looks like what we were doing with all these orchestrators in the past, but more dynamically, I would say. When it comes to chatbots, I would say a chatbot is more like a multiple task-specific agent, but with a global orchestrator and a fallback when it doesn't land in one of the sub-agents that are like able to do stuff autonomously. This is a term that I've just introduced, which is like sub-agents, because when we do AI agents, we don't have a unique agent most of the time. We also have like sub-agents. There is like a page on the Cloud Code website that explain what are sub-agents and what are like the benefits. I would say that are the four biggest benefits that you can have from sub-agents. The first one is the context preservation, because everything that you do within a sub-agent stays in a sub-agent, and the sub-agents can expose only what it thinks is the best to the orchestrator, or the orchestrator can extract only the context that is relevant to the main loop from the sub-agent runtime. We can specialize some expertise on some stuff. We can have flexible permission on the tools that the sub-agent can use. And once a sub-agent has been created, it can be reused across everything. But all of this is context engineering. And the way you should design all the stuff that you do is you should think about the tools as replacement of tasks you would do as a human, or actually as a data engineer. When you develop the tools, when you develop the thing, actually it's a bit like we were developing Airflow DAGs in the past. When you were like designing an Airflow DAG, you were thinking about, okay, what are like the tasks that I do manually that I want to automate? And when you do it for an agent, that's a bit the same. Like the way you should think about the tools should be a bit the same. The tools that we give to agents, most of the times, I would say, fall into these four categories. The first one is search. So it's like everything that is related to finding the relevant context for a given prompt. Then once you have find something, you want to read it. So once a context has been found, we need to read it to give it to the LLMs. Then there are tools that are doing alteration of the file system, the database, the whatever you use as an underlying system. But at some point, you need to apply the changes that the LLM wants to apply. And then there are like the tools that are more around agent management. So all the sub-agents, the planification, the memory management, and this kind of thing. I have the most basic bash agent that you can develop. So for instance, when you have a bash agent, the search gonna be like ls grep, the read gonna be like cat, for instance, the write gonna be like the greater than operator, so the send operator, and the agent management, when you do just a bash one, you don't care about it. You can build like, for instance, data agents on top of your data warehouse. So the search is gonna be like list the tables, search the tables with pattern matching, for instance. The read gonna be get the table schema, add, so get the first 5 lines of a table, get the profiling, get the distribution, or just, for instance, run a select on a table. The write, I think you don't want a data agent to be able to write on your warehouse, but if you want to do it, go for it. And then you can have like some agent management. So for instance, you can need some kind of data diff or profiling agents to verify that the 3 first tools didn't like break something, or that the difference between the previous state and the current state is not that big of a deal or something like this. You can have data agent on top of a DBT project, for instance. But what I want to say is everything is, once again, context engineering. But what is context engineering? Context, this is a slide that I've taken from something that I've put in the resources. Context engineering is a bit of all these concepts that we have here in the bubble. So it's a bit of RAG, it's a bit of prompt engineering, it's a bit of managing the state or the history of the conversation. It's a bit of the memory. How do you identify patterns that the users have? It's a bit of structure output, and structure output in this bubble is more related to the tools, because the way this slide has been done is like structure output is a replacement for tools. So here, structure output is a bit of the tools. And when you look at this, doing a RAG, doing memory implementation or management, doing state or history management, actually this is really like data engineering in a sense of you have a lot of information that is related to a conversation or relating to a project or related to some stuff an AI agent is doing. And from all this information that you have, you need to put this information into a database or a storage to be searchable very fast in order for the AI to be able to query it and get it. And I would say it's close to stuff that we are doing in data engineering when it comes to real-time system with like feature engineering or feature store or stuff like this, where we have like a lot of data, we compute stuff on top of the data, and we make this data available to a real-time system in order like to do some kind of prediction or augment the context. So this is actually data engineering. This is a way to schematize what is a context window, and the context window is 100K token to 1 million plus token, can be 2 million, for instance, for Gemini or even more. And the way you structure the context window is super important. I would say that you should try to structure it this way. So first you go with the system prompt or the tools, both can be changed. I would say tools should be first. Then you have like the memory, you have the user roles that the user define. Then you have all this space where you put like the current conversation. And when I say the current conversation, it's like the history of the user messages, the history of the tools answers and questions, the history of the LLM answers. And here, this is super important. This is here that you have a lot of management to do. And then you have to keep space for like the token generation. There is something that you have to have in mind, which is you can do cache of the context window. The first cache breakpoint, which is all this for, gonna be easy to do. Whereas the second one, which is on the current conversation, might be hard to manage depending on how you structure your context. This is a slide that I've extracted from this talk called Advanced Context Engineering for Agents. And I really agree with this. What are like the main context issues that we have when we are building AI agents? The first one is we have in our context, so in this, incorrect information. We have missing information sometimes, and we also have too much noise or too much information. And all these three things have to be tuned and fine-tuned to be the best, because you will have to get the best context window in order for the agent to be the more efficient to answer an issue that we have. So you will need to invalidate or remove context. You will need to identify that you are missing something. You will need to sometimes resteer the goal because you have lost the goal and the thing you want to do. And for this, you can use like sub-agents that compacts very much like the context window. You can clean the errors when you have errors in the current conversation. Just remove the errors once they have been fixed. You can let an orchestrator LLM decide what stays or not in the context. You can do some summarization. You can plan. You can rag on the previous messages. You have to compact information in the end. And so if I have to sum it up, I would say you need to aim for the smallest context window while you are trying to fit all the needed information inside. So it's like super hard because you want the smallest context window, but you want to put everything inside. That is relevant. So this is something that you have in mind. You can do some experiment and let the LLM decide what goes in the memory or not. You have like a lot of things to try to make it work for use cases. In the end, I would say it's the biggest automation we've seen. and yeah, you have to learn to use it. And that would be all for me. Just I give you like a few resources if you want to go further. There is like this repo called 12 factor agent that is super good at giving you ideas on how you should build agents. There is this article from Anthropic Research or how they build their multi-agent research system. And there is the blog that we have where we write some stuff. So it's called the new AI Order on Substack. You can subscribe there. We are publishing like cool articles about how we build AI agents for data stuff. And that's all for the presentation. Here are the takeaways that I already gave at the beginning of the presentation. So context engineering is everything. You have to try to build yourself an agent from scratch. And obviously there are limitations, but you have to know what are the limitations in your use cases to be better at building AI agents. And that's all. That's me. You can add me on LinkedIn or try now on getnow.io. I hope, I don't know if there are like any questions in the chat.
It looks like we have one from PK.
What strategy do you need to come up with for streaming big data with agentic architecture? Yeah, that's a good point. So this is something that you have to figure out with your architecture and your limitation in your enterprise. But I think it's not super good to send a lot of data into the LLM because, to be honest, like the LLM, so you don't want to pollute the context window, and the context window is quite small compared to big data, I would say. So you have to find some tricks. The one that we found that works are sending the LLM the schema of the thing you work on. So if it's an event, you can send the schema of the event, and then sending some sample of interesting events, I would say. So if you can send like the last 5 events that goes through like the streaming system, it's a good idea. If you can send some kind of profiling of the events, it's a good idea. I think you need to find like not a lot of data, but just the particular data that is in your big data streaming system. I would say it this way.